As we start talking about the dynamic processors that we have available, they're going to be our expanders, gates, compressors, and limiters. And all of these have really the same basic fundamental functional components in that they're all split up into two segments. And we saw with the vocal riding example that you have to kind of listen to the vocal, analyze it, and respond to it. And all these devices are doing just that. They have one section that's designed to analyze the input signal. That's called the sidechain section or the key section. And the other section of it is really just a volume fader. It just brings it up and down. So the first thing I'd like to look at is that kind of key or sidechain section. Its role is to analyze the signal and calculate the envelope of the audio. And the envelope is kind of a signal that represents the average level at any point in time. And though it seems like a simple thing to do, it actually is kind of complicated. And the way it happens is, and you've seen this term, I'm sure, is RMS, which stands for root mean squared. And so it's trying to calculate the average level over a little bit of time of that signal. But sound, as we saw, is alternating. It's going up and down and up and down. So if we were just to average out the sound, it would always end up at zero, because it spends just as much time above as below zero. So we need a mathematical process to kind of give us the average level over time. So what we do is first square the signal. We take every sample and multiply it by itself. And anytime you multiply something by itself, you get a positive number, right? A negative times a negative is a positive, and a positive times a positive is a positive. So every single sample is multiplied by itself, giving us a completely positive version of the signal. And then we can take an average. So we might say over 30 samples or 50 or 100 samples, we take an average of it, which gives us a nice slowly moving envelope. And then we take the square root of that to get it back into a reasonable range. So we see the RMS all the time, and really all RMS is kind of an average level of what's going on in the signal. Once we have that information, once we have that envelope, we can use it to control the volume fader, right? So in our vocal riding example, we saw when the signal got loud, we brought the level down. And that's functioning like a compressor does. So a compressor has that volume fader, and whenever the envelope goes up, the volume fader goes down. Same thing we were doing with vocal riding. Now, when we're kind of programming this robot that's going to help us move the volume fader, we have a couple of parameters that we're going to need to configure. The first is at what point does he start bringing down the level? And that's going to be our threshold. And all these dynamic devices are going to have a specific threshold. And in a compressor, when we're below that threshold, the compressor does nothing. It's completely linear below the threshold. Once the envelope gets above that threshold, which we can set at any point we like, then the level will start coming down. Now, how much it comes down is the ratio. The ratio will always be expressed as a number to 1, something over 1. And that's going to be input to output above the threshold. So if we have a 1-to-1 ratio, above the threshold, nothing happens. Input equals output. If I had a 2-to-1 ratio, that's saying if the input goes up 2 decibels, the output only goes up 1 decibel. So above the threshold, the output will be half the level of the input. And then we can keep on going up with that ratio. In fact, a limiter is a compressor with a very high ratio. We usually consider above 10-to-1 to be limiting instead of compression. So they're really the same device, a compressor and a limiter, with that one thing changed. So threshold will always need to be adjusted no matter what signal you're going through it. You can't rely on a preset to set your threshold, because threshold has to be related to the underlying musical material. If you have someone playing quite quietly, they'll never hit that threshold, so the compressor won't do anything. If you're someone that's always playing loud, he might always be above the threshold, maybe not what you want. So you'll always have to adjust that. Ratio, you're going to adjust for how much reduction you really want the compressor to give you. The other parameters we're going to have to address are how fast that volume fader moves. And that's going to be your attack and your release parameters. They're going to control how fast that robot moves that volume fader for you. The lower, and they're expressed in an amount of time, usually in milliseconds. So the lower they are, the faster that volume fader will move. And when I think of attack and release, I like to think of it as they're functioning at the beginning of the sound, or at the transient. Because for a compressor, attack is going to be how fast the volume fader comes down once the sound goes above the threshold. Release is going to be how fast the fader comes back up after the sound has gone below the threshold. And they can be set differently. So you can have the robot move the fader really quick down and then slowly back up, or move it down slowly and come back up quickly. And all those things have a great impact on the end result of the sound. And the challenge of working with these dynamic processors is all these controls are kind of interrelated. And it really requires a deep understanding of their functionality before you can use them in a musical way. Now, those are the main parameters you're going to have to deal with all the dynamic effects. Again, that's threshold, the point at which the dynamic effect starts functioning. Ratio, how much it functions once it crosses the threshold. Attack, how fast the fader moves or the volume will change at the beginning of the sound when the sound crosses the threshold. And release, how fast the fader moves or the volume changes when the signal crosses back through the threshold. Now, there are some other parameters you'll see on most dynamic effects. The first one is knee. And that's going to be, if you can imagine the threshold as kind of a point, right? And we've described this as kind of an on-off procedure, where as soon as the signal crosses that threshold, the volume starts changing. But that's really kind of a not very musical thing, right? Everything in nature is all curves. And that's what the knee gives us, is as we approach the threshold, we'll start moving a little bit as we get there. So it kind of softens that out. And if you have a signal that's crossing the threshold a lot, increasing the knee can kind of soften the effect and make it a little more comfortable for the listener. We'll also see a look-ahead parameter on many dynamic effects. And the look-ahead parameter is a delay imposed on the signal, but not imposed on the envelope. And what that does is it makes it so that the envelope is seeing a little bit into the future, in that the envelope parameter is seeing maybe 10 milliseconds before the volume fader actually gets there. So if we set that high, we can actually reduce the level before the transient actually happens. So it can be a really effective limiter or compressor, and that it can stop that transient even before it happens. So we've seen the most important parameters of all dynamic effects. And honestly, it is difficult. We're going to start now going through individual effects and seeing how we can manipulate the parameters on them. We'll look at expanders and gates, and then we'll look at compressors and limiters and see how we actually manipulate those parameters for a musical effect.